Good evening to all. Today we are starting with our BEE series, and in BEE series I already explained in previous videos that we are going to cover the basic concept first, because BEE subject is a basically combination of basic concept first. If you don't clear the basic concept, आगे बहुत मुश्किल होने वाले. That's why my suggestion that try to understand basic component of each and every circuit. So today I am starting with the basic fundamental, basic fundamental. So first definition in basic fundamental is what is a electrical circuit. What is a electrical circuit? So most of the time there is one diagram. If I take resistance, inductance and capacitance, this is my first diagram called as R, L and C. This is my first diagram. And in second diagram, if I use the same thing, that is R, then L and then C, and if I connect a voltage source across it, and if there is a voltage source, there is a passing of current. So my first question to all of you, that is, out of these two, one is an electrical circuit and one is an electrical network. So which one is an electrical circuit and which one is an electrical network? So when you design the circuit, basically you hire the component, you connect the component, and one structure is created. That structure is always called as electrical network. Electrical network. But what is the difference between electrical network and electrical circuit now? When you connect the voltage source or driving force in this network, then there is a passing of current, then it is called as electrical circuit. So in basic electrical engineering, entire syllabus is rotated around the electrical circuit concept. Rotated around electrical circuit concept. So after clearing the definition of electrical circuit, so what is the definition of electrical circuit? It is a connection of all electrical component, but at least one closed path should be there. So when there is a one closed path, flow of electric current will take place, and that part is called as electrical circuit. So now question in our mind, that is, what are the different types of electrical circuit? Electrical circuit basically get classified into two parts. One is known as DC circuit, one is known as a DC circuit, and another is known as AC circuit. DC circuit and AC circuit. You are already aware about DC circuit. When we connect the source DC to the resistance, and if you connect the closed path, then there is a flow of electric current that is called as I. This is R and this is a V. So how many components you observe in your DC circuit? So basically three components are there. One is called as voltage source, one is called as voltage source, another is called as current source, and third one is known as resistance. So only three components are present in DC circuit. So what is the difference in DC and AC circuit? Only change of source take place. Instead of DC there is a AC source, but instead of R there are two more components we are already familiar, that is L, then C. So this is RLC, and again there is a flow of current that is equals to I. So how many components are there? Now in AC there are five components. One is AC voltage source, one is AC voltage source, second is current source, third is resistance, then fourth is inductance, and the last is capacitance. Last is capacitance. So first we observe what is the definition of electrical circuit. The electrical circuit consists at least one closed path so that electric current passes through it. That's why it is an electrical circuit. Get classified into two parts. One is called as a DC circuit, another is known as AC circuit. In DC circuit we observe the three basic components: voltage source, current source, resistance. But in AC we observe the five components: voltage source, current source, resistance, inductance and capacitance. So if you want to clear the concept of BEE, all five parameters should get, basic concept of all five parameters should get clear, and that's why this series we start with the first part, that is common device in both, that is called as resistance. That's why we will go for now concept of resistance, we clear that, and then we'll go for inductance, capacitance, voltage source and current source. So that is called as basic fundamental. So without wasting time, let's start with the first component, that is called as resistance. I know that everybody is aware about what is the definition of resistance. Basically, when there is a disturbance in road, like that, there is a disturbance in flow of electric current, that is always called as resistance. So opposition to the flow of electric current is always called as resistance. So resistance is always highlighted by two symbols. First is either R, or in some books it is shown a box and R. So this is a symbolic representation of resistance. You are already aware about this, so I am not going so detailed. So this is the meaning behind resistance. So once again I repeat, what is the resistance? Opposition to the flow of electric current, and this is the symbolic representation of resistance. If you go by mass, then resistance is invented by ohms, and according to ohms, definition of resistance equals to V by I, and if you go by construction, definition of resistance will be rho L by A. So this is a mathematical representation of resistance, and this is the symbolic representation of resistance. So this is the first part, what is the meaning of resistance, and that part is already covered from 8-9 standard, and you are already familiar to this. But our first topic always create a problem, that is called as series and parallel connection of resistance. So I'll go for the next point, that is called as properties of resistance. Properties of resistance. So first property of resistance, that is called as resistance in series. First property is known as resistance first property will be resistance in series. Now question in your mind, we are already familiar to the formula why it is, but I'll give the concept when you have to say series or not. So first property, resistance in series. So you're already aware that if I take two resistance, name as a R1 and R2, name as a R1 and R2, and if anybody asks you what is the equivalent resistance between terminal A and B, then you can easily say that is RAB equals to rega R1 plus R2. Very simple and straightforward definition as well as the calculation. So what is the first property of resistance? Resistance are always additive when they are connected in series. But now question in our mind, how many resistance are there? Only two. So we can easily say that they are in series. But what will happen if you come across the complex network and you have to identify whether two resistances are in series or not? For that particular purpose, next important point रहेगा identity of series resistance. Identity of series resistance. And another request to all of you, that when I am teaching, you also start writing. Then writing always gives you better property. So first point, what is the resistance we are cover? Resistance are always additive when they are connected in series. That's why formula become RAB equals to R1 plus R2. Up to this part, everybody is aware about the resistance and combination. Now the important point for us, how to identify series resistance. So now to identify the series resistance, I'll take two combination of series resistance. One is R1, another is R2 across terminal A and B. Same here. Another combination R1 and R2 across terminal A and B, across terminal A and B. So this is again R1 and R2. And if you now closely observe this combination, I'll say this resistance start from this end. So I say starting one, finishing one. This resistance start from here to starting two, finishing two. Same here. If I say this resistance start from here to starting one, finishing one. And this resistance start from here, that's why it is a starting 2 and finishing 2. So I'll mark the terminal according to their connection style, because R1 is start from here, and that's why starting 1, get finish here, that's why finishing 1, starting 2, finishing 2. If you now closely observe, two resistances are in series if their one end get connected, so that if I pass current I from here, this current also remain I. So another important property of series resistance that they must be contribute same current. When you say that two resistances are in series, another important point that they must be carry the same current. Like that, when two friends are there, they have same thinking, then and then only they can become the friend. So series is a support always, and that's why you can say two resistances are in series. Same combination. But if I make minor change here, if I put one extension here, if I put one extension here, what will happen here? Even though there is one end get connected, so like previous example, you can say yes, they are in series, but if I pass current I here, this current get divided in terms of I1 and I2, I1 and I2. So even though they look like a series, they are not in series and they are in series. So what is the basic property of series resistors? Their one end must be get connected directly without any extension. If there is an extension, then you can say they are not in series. What is the reason? Reason is they contribute different current. So this is the identity of series resistance, whether two resistances are in series or not. After identification, when you solve the problem, then most of the people, when you reduce the circuit, most of the time you have to reduce the circuit. In circuit reduction, what will happen that when you replace two resistors, what are the replacement rule? So my next interesting point in terms of series resistance is what is the replacement rule. I am writing here, that is replacement of series resistance. How you replace the series resistance in circuit reduction. So for example, if I have combination of two series resistance, again R1 and R2, and again I say R1 and R2. So it is already clear that they are in series because their one end get connected directly across terminal, suppose A and B, and across terminal again suppose A and B. So already I say the formula that when two resistances are in series, their equivalent will be RAB, that is R1 plus R2. That is a simple calculation. But how you replace? So what is the replacement rule? That R1 parallel R2, R1 parallel R2 will be the R1 parallel R2 will be the RAB, and that RAB you can replace at one place, while remaining place is replaced by short circuit, or you can say straight line. So for example, this is A and B terminal, my new replacement. I am replacing equivalent resistance RAB at place of R1, but important point, remaining place R2 will be remained by short circuit. So this is the first replacement rule, or you can say that I can replace R1 by short circuit and R2 remain as it is across terminal A and B, and that's why it is R1, it is R2, but I am replacing now RAB at place of R2. So what is the replacement rule? When two resistances are in series, their equivalent will be 100% रहेगा RAB, formula you already know, and that RAB either you can replace at place of R1 or either you can replace at place of R2. But what is the meaning of, what is the purpose of second, what is the you have to do for second resistance? It should be replaced by a straight line, or in electrical concept it is called as short circuit. So once again I revise first topic, that is series resistance. What is the formula, how to identify, and the most important, how to replace it. So that is about the first part, resistance in series. Now we'll go ahead, another today's interesting topic, that is called as resistance in parallel. That is also covered in 12th standard, but just revision point of view, resistance are in parallel. So if I take two resistance in parallel across terminal A and B, that is suppose R1, this is suppose my R2 across terminal A and B. The first important point, that is how you calculate the parallel equivalent resistance. So to calculate the parallel equivalent resistance, first point that you have to do the formula, and you know that what is a parallel equivalent? 1 by RAB equals to 1 by R1 plus 1 by R2. And if you simplify, then final formula रहेगा RAB equals to R1 R2 divided by R1 plus R2. So this is a simple meaning, already derivation is covered in 12th standard, so I am not wasting the time. This is the formula to calculate the parallel equivalent resistance. So this is the first part, how to get the parallel equivalent resistance of any combination. Okay, two resistances are there, so you can easily say they are parallel. But in complex network, how you identify that whether they are in parallel or not? For that, next point as usual रहेगा, what is the identity of parallel resistance? Identity of parallel resistance. So for that particular purpose, I am taking the first another combination of resistances, that is, suppose I take two resistance in parallel, okay, and we try to observe them, what kind of relation they develop, so that we can say they are in parallel. So this is again R1, this is again R2. Now if I analyze same like a previous, that is a starting and finishing end, so this has become my starting terminal, this has become finishing terminal for 1, this has become starting terminal 2, finishing terminal 2, and now try to observe what will happen here. That is, when two resistances are in parallel, their both end, matlab starting end as well as finishing end must be connected. Extension is not important in parallel. Parallel, what is important? The starting end and finishing ends should be get connected, so that if I pass current I here, this current become I1, this current become I2, and overall current become equals to I. So what is the difference between series and parallel? Two resistances are in series if their one end without extension must be connected together, but in parallel both end. Extension is not important, both ends should connected so that they contribute different current. So series resistance contributes same current and parallel resistance contribute different current. Series means dosti. So in dosti they think same, that's why they carry the same current, but in parallel they are. So basically in electrical circuit, series is a support and parallel is a oppose. When there is opposition, two different current are passing through this, and that is possible if that both end get connected together. So this is the meaning behind identity of parallel resistance. And the last point in case of second property, that is replacement rule for parallel. Like series, replacement rule for parallel. So suppose I have again combination of parallel, that is R1, then I can say R2 across terminal A and B, and now I am interested to simplify it, because we know that when two resistors are in parallel, we'll get equivalent resistance, that is called as RAD. Where to replace? Same rule like series, that you can replace at place of R1 or you can replace at place of R2. But what about the remaining place? Remaining place is always replaced by open circuit. In series, it is always replaced by short circuit, but in parallel, it is replaced by open circuit. So RAB, either you can replace at place of R1, or either you can replace at place of R2, but remaining place is replaced by open circuit. The simple meaning, because in circuit reduction and when you solve the problem, always keep in mind, student always make mistake when they create the new diagrams. Why? Because they don't know the basic, how to do the replacement. In series, you can replace series equivalent at one place, remaining place straight line. In parallel, you can replace parallel equivalent at one place, but remaining place will be replaced by open circuit. So in this video, we observe the two important things about the series resistance. Two properties of resistance. First is in series, they are additive. In parallel, they are additive but inversely additive. So both formulas, how to identify series resistance in complex network, how to identify parallel resistance in complex network, and last but most important, how to replace the parallel equivalents when you simplify the circuit diagram. Next lecture will go for the another properties of resistance, and they are very important, called as short circuit and open circuit. Till then, bye.